Okay, let's go. So question 8c, right? Calculate an estimated value for the acceleration of the car at the instant when the time of the velocity is 12.5, right? So, and the question says from figure 8, from figure 8. So you have to use the figure, okay? So you look at the point where the velocity is 12.5, right? So this is 10. Can you see my cursor? This is 10, this is 15, it must be around here, right? And you want the acceleration, right? Acceleration. So if you're given a velocity or speed time graph, the acceleration is essentially the gradient, right? Essentially the gradient. Right? So here, just draw the gradient, you should have the answer. So this is not that bad an issue, right? One of the things that you need to note is this. When you take gradient, you want the line as long as possible. Right? Of course, here the solution is a little bit, it doesn't extend fully, right? But if you extend the line fully, you should be able to still be able to see it. Right? I suggest a line that's as long as possible, and I want you to see this. This is one of the ways to judge whether your gradient line is good or bad. I have a few students, the gradient point is out of range. I mean, the gradient value is out of range. So you look at this. Can you see the thin blue line and the contact? This is one method to look at it. So actually the center point is here. Okay? So if you take 3 squares to the right, 1, 2, 3, how far is it above the line? Okay, and take 3 squares to the left, 1, 2, 3, how far is it above the line? It should be about the same. Okay, Ken? That is one way to judge your tilt. Is it more or less there? Okay, so that's one way. The other way is to look at the angle. If you don't find the angle here and angle here, between the black line and the blue line, it should also be about the same on both sides. So this is one way to judge symmetry of it. Ken? Moving on. 8D, calculate the driving force when the velocity is at this velocity. So here is a tricky question because a lot of students, FD equals to FMA and done. They forgot that there was something else in the question. Right? A lot of students just put FD equals to MA and they solve and they get the wrong answer. But here, don't forget that there is a resistive force. So the driving force, if you draw the free body diagram, it will help you look at the question. So this is my advice. Whenever you have forces and you have an object, draw the free body diagram. Right? Okay, they didn't draw, so I draw for you. Right, in the question, to understand the question situation better, draw the diagram. So if you have a car, oops, my car not so good. You have a driving force. Oh, sorry, I think my S42 cars are all gone. Hello? Yeah, we are in LT4. Yeah, we're all waiting. Actually, we are not waiting, we started already. Yeah. Okay, bye-bye. And all this is recorded. Okay, so you have the driving force FD, right? And you're asked to find this. But a lot of students forget that there is a resistive force given by BB squared. Okay? So we have previously found B to a certain value, right? We have previously found B to be, or rather we show that it's 0.49. You know that the velocity is 12.5 meters per second. So you can essentially calculate this. So the final should be FD minus FR equals to M with the acceleration you have calculated in part C. So you can see your solutions build one upon the other. So if you have any mistakes in the previous part, there should be error carried forward. Okay? And I realized also towards question 8 and 9, more students are making mistakes in SF. Because by then I already forgot, Mr. Ho keeps saying 3SS, 3SS, but you forgot already. So you write 1746, you just write the exact value and you make the mistake. So anyway, you get the answer 1750. Any questions here? So depending on your answer in part C, right, we will calculate the value of FD accordingly. Okay, next question, part E. Calculate the power of the car to overcome the drag when it's traveling at its terminal velocity. So you must find out what the terminal velocity is. It is at 27.5 meters per second, right? And the value of B is 0.49. So again, we can look at the diagram. So if it's traveling at terminal velocity, FD and FR must be equal, right? So power is driving force times velocity. At terminal velocity, FD equals FR, so it's FR times velocity. And FR we have found in earlier part says BV squared times V, so you get BV cubed. Okay, so that's the equation that you should be using. Any questions here? Please, okay, so instead of me asking questions, just feel free to interrupt me at any point in time, okay? Right, so you have this. Then once you have the equation, right, that's the hard part. The easy part is just to get the value. So you notice this to be the same for many physics questions. The hard part is not substituting and getting a number, that one is math and your secondary school work. The hard part is getting the equation. And that's the physics part. Right, so part F is kind of like a repeat, right? If you know part E, you know part F. Also, it's a little bit unfair. I would have preferred a slightly different concept being tested, but it's the same concept being tested. So here, what would you do if you didn't get the answer for part E? Yes, you anyhow guess answer in part E. You will write down P equals to 1. Crazy answer, right? P equals to 1. Let's say your part E do not answer. You just write P equals to 1 in part E, get that wrong, and then you substitute it in part F. And you say, I don't know the equation. Well, then that's too bad. But if you know the equation, you can actually get this, right, and solve for this. Okay? So you have to still know the equation and solve for it. Okay, part E and part F the same thing, so we can move on. The one behind it is very, very difficult. Part G is like out of the world kind of question. Very, very, very difficult. I'm not kidding. So the question says the car is now moving at the terminal velocity into a headwind of this velocity. State an expression for the new drag force. Right, and the calculated power now required. So moving the headwind, you're finding the effective wind velocity now, right, to find the drag force, because drag force depends on the headwind. Right, when you're standing still and a wind of 10 meters per second is blowing on you, it's the same as if you're running at 3 meters per second and a wind is blowing forward at you at 7 meters per second. Those of you who are in track and field should know this, right? With a headwind, do you know? Okay, very good. Right, but if you have a tailwind, what happens? It becomes easier to run, right? You run faster. Right, but however, the tricky part is this, no? The power is not that combined velocity. Because the power is that the velocity is Fv is the real velocity of the car in relation to any other human being on the road. That means the real velocity of the car, not the relative velocity. So this is the tricky part. This part, I did not expect any student to get. But some students got it, which is amazing. Or maybe they just, just guess. But this is wonderful. So a few students got this. Any questions here for question 8F? Also, note that the two V's are different. One, the inside is the relative V because due to the wind. This V is power Fv, power is F times V, but that V is the real velocity relative to an observer outside. Minus? They are going in opposite direction. So you must then exert even more drag force, right? Right, when you are standing still and you have a wind blowing at you at 7 meters per second, and your wind blowing at you at 10 meters per second, which one has more drag force? The one with a higher velocity. So if you are running into a headwind, the drag force must be increased rather than decreased. Quite a few students took minus, but that would be wrong. Minus is when the wind is from behind you and moving in the direction of the car. Okay? Questions? Sorry? Why can't it just be cube? Yeah, because the last V, right? Okay. Let me draw it out. So the power equals to Fv. This is how we all remember it, right? But we have to be very specific. F is the force by car. V is the V of the car, the real V of the car, correct? And in this equation, at terminal velocity, the force by car is then equals to the resistive force. Agree? And resistive force is given by V squared. But this V is the relative V. This V is the relative V. The sponge smells funny. I think whenever I breathe, I'm sucking in bacteria. But this is also bad. Okay. Alright, so this V of car, and this is not the same. It's the relative V between the car and the air. So hence you cannot just cube the thing. Alright, Angela? Right. Part H. H is a little bit unfair. Okay, a little bit difficult. Okay, we were expecting a little bit more from students. Here, you're asked to find C subscript D, the drag coefficient. Right, the drag coefficient. So all you have to do is to put the equation down. However, there is one estimation you need to do, and that one was the one that tripped up a lot of students. Okay, is this. B equals to, you rearrange, but you need to estimate the value of the density of air. There was actually one tutorial question, right, that we had the density of air mentioned. And in class, we estimated it to be around 1 kg per meter cube. I know. Right? Unfortunately, in this marking scheme, right, because each examiner has their own standards, they require to this standard of 1.2, they require to the 0.2. Unfortunately, so hence you didn't get the full credit. Okay, and they accepted this range, okay, between 1.1 to 1.3. Okay. Sorry lah. Sorry. But I respect those of you who got 1, good, you were listening in class. Okay? Probably in a Cambridge marking scheme, it is possible, probable that they will mark it correct because that is a good enough estimation. But now that you know 1.2, please remember it and just use 1.2. Okay? Right. Once you have that, the rest is easy peasy. You can get 0.33, not an issue. Next, part I, the drag force is proportional to the square of the air velocity. Explain on the basis of the Newton's second law why when the velocity is doubled. Part I, so many of you got it wrong, right? The question is not asking you to explain the mathematics of F equals to BV squared. No. Because if you just explain the math, right, when V is 2V, the F is 4F. But that's not what they're asking. Because they say on the basis of Newton's second law, they're asking for the physical reason behind. So you must analyze how the air molecules hit the car. That means you're asking the underlying reason, how do you even get BV squared in the first place? So you think about how the air molecules hit the car, so on and so forth. So there are actually 2 reasons. When the velocity is doubled, 2 things happen. Okay? The speed and the mass of the speed of the air impacting the car must be doubled. Right? Because if you are doubling your speed, it's as if you're not moving and the wind is blowing at you at double the speed. You're traveling at 10 meters per second as if you're not moving and the wind is traveling at 10 meters. And if that double that speed, that means the momentum of the air molecules is doubled. That's number 1. Number 2, the rate of mass hitting you will also be doubled. So your momentum is essentially quadrupled. Okay? And that explains why air resistance is proportional to V squared. Right, in this case. Okay? So you have this, then you just use Newton's second law. Since the momentum now is quadrupled, the change in momentum states that the force must then be quadrupled. Questions for 8, part I. One of the harder questions around. Why is it quadruple? So let me use some mathematics to show you. Okay? So if you have this surface area, you are moving forward, you have this surface area. You will bounce into a series of air molecules. Bounce into a series of air molecules. So if you have this velocity v moving forward, it's as if you don't have this velocity v and it's the molecules that are moving to you with this velocity v. This part can get relative velocity. Ready? Okay. So now, if your initial velocity is v, you will have m molecules hitting you. The mass of each molecule is m. You will have each molecule is m. For example, you have n mass hitting you because there's maybe 10 molecules hitting you. Each of mass m, you have 10 m molecules hitting you. Agree? If I now double the speed, what's the mass of molecules that will hit you? You have double, right? So your mass will be then, if you double the speed, if v double, the mass hitting you will be 2nm because you will have more air hitting you in the same amount of time. Next, the velocity of each air, right? So the mass part is this, the new mass is this. The new velocity will be 2v. So the new momentum will be 2nm, 2v equals to 4nmv. And nmv is the initial momentum. So we must make some assumptions that when the M velocity hit you, either they lose all their momentum or half their momentum, whatever, but it will still be the same. Okay, so assuming they lose all their momentum, initially, the initial momentum loss is NMV, which means the force is change in momentum over change in time equals to NMV change in time, whatever that change in time is, whatever that value is. But now the new force is the new momentum over the same change in time, and you realize that it's 4 NMV change in time, which is 4 times of that. Okay, so this is the reason behind. Okay? So if you really want, you can actually calculate mass in terms of velocity. The mass that you encounter in terms of velocity. It has to do something with the density of air. You can get the equation out. Okay? Other questions for 8? If not, let's move on to number 9. Number 9 is actually, I thought that it was easy. Right, the first half was relatively easy, but I was a little bit surprised. Like angular velocity, this mark is yours. Right, just read the notes, Control-C, Control-V, cut and paste it from your brain to the paper. Right, so not an issue. Let's move on. The 9 part B, calculate the resultant force on the man. So here, some students start to make mistakes. I think it's the last question, right? Then timing-wise, not so nice, right? You need to read that it's a constant angular velocity. That means the man is moving at a constant velocity, constant angular velocity. It means that the net force on the man must be constant. Okay, the net force on the man must be constant. And that is what you are calculating. So using mv squared over r or mr omega squared, we can find the answer. And in this case, you are given the omega. That's why you use mr omega squared. Here. Okay, we use mr omega squared because we are given the omega. 9b, most students got it, right? Most students got it. Those who didn't probably got a bit worried, right? And frazzled. 9c, explain why the man remains in contact with the floor at cage position C, which is the top. Suggest and explain your. So this is also a very standard kind of question in circular motion. I suppose you remember in the lecture, the lecturer swung a bottle upside down that is uncapped. Why did the water remain at the top, remain in contact with the bottle at the top of the movement? It is exactly the same question as part C. Okay? So there are a few ways to go around it. Let's look at what answer they say and we copy the format. So they say let n be the contact force. Did they say use calculations? Yeah, support your answer with explanation and calculations. Well done. So there are a few variants to this. In some Cambridge questions and in some exam questions, they don't ask you to calculate. They say explain your answer. Okay? So I'll do that later on, but let me go through this one first. So here, they say that at the top of the movement, the forces that provides circular motion is like that. Right? If I were to draw the diagram. So you notice that the answers that we give do not include diagrams. So you have to illustrate it yourself. Can I say again? When you solve questions, right, for the first 7, 8 topics until gravitation, you should draw free body diagrams. Because it helps to clarify your thinking. Not because I ask you to draw, but because it helps you. So, if you have at position C, Right, what acts on the man? This is the man, the head. Okay? There will be N, normal contact force from there, and you have also mg, the man. Okay, and you see that N plus mg must provide for centripetal force, which is in this case m r omega squared, which you already calculated to be 1180. Okay, so what you need to then do is calculate the value of mg. The value of mg you realize is smaller than 1180, which means that n must be bigger than 0, which then explains that why the man remains in contact. Question for this one. Calculation is pretty easy, right? Rayan, you look lost. Can I help you? Can, no problem. So you start off with a free body diagram and you look at what forces are available on the man at the top. There are two forces. There's the weight of the man itself and normal contact force. These two should provide this. If you want to experience this normal contact force, right, all you have to do is take a Coke bottle, fill it half with water, screw on the tap, let it screw on, right, and you swing it as hard as you can. You find that the Coke bottle wants to move away from you, and you're actually holding it in. And the holding in, that force is equal or similar in direction to the force N applied on the water to hold the water in. So when this thing is going fast, this man is experiencing this N force holding him in. Okay? Yeah. So mg, of course, still acts because that's due to gravity. That will always be present. Right, then m omega squared. So you already found the centripetal force 1180 at the beginning. Then you can find the value of the weight here. And you find the value of the weight must be less than 1180, which means that n must be bigger than 0. And if n is bigger than 0, there is a contact force, it is then in contact. Okay? What this also means is that if I now slow down the circular motion from very fast to slower and slower and slower, at a certain speed, the man will fall off and knock his head at the top of the cage. And then when he comes down again, he will knock the bottom of the cage, right? I think he will concuss. Okay? Questions? This concept must understand. Important. You will, okay, what's the value of the man? mg is equal to what? What's the mass of the man? 60, right? G is 9.81, right? So this gives me around 600 Newton. Correct? This means that N equals to 1180, roughly equals to minus 600, which is roughly equals to another 600, 580. It means that N is not 0. That's basically what I'm trying to say. Which means that I can slow down until N becomes close to 0. Right? If I slow this down, boys and girls, let's do a different question now. If I slow it down, let's say I slow down, what will happen? This omega will drop, right? Right. So let me change the color to show there's a different thing. If I reduce the omega, I can reduce this to 1,000, right? mg stays the same, correct? So what's the contact force? It becomes 400. Becomes 400. Agree? Can I slow it down further? I can slow it down even further. Let's say I slow it down to 800. What will your contact force? It will be 200. Is it still in contact? Yes. Can I slow it down further? I slow it down to 600. This will become 0. Just lose contact. Can I slow it down even further? Yes. 400. I don't think this guy can even reach the top. Halfway, he will fall off. Okay, Ken? So this is an important concept to grasp for all exams, okay, in the future. Next, part E, describe and explain the changes in potential energy of the man from A to C. Now this question, I was a little bit shocked. I think if I didn't teach circular motion, and I give you this question during your O levels, you can actually get it correct. Because you see that the man is doing constant motion, the velocity is constant. But he went up, so GP must increase. Correct? So your answer should be no change in KE, GP increase. Correct? But after teaching circular motion, many of you start to have this idea that, oh, your GP will be converted to KE, which is the other situation of vertical circular motion. There's two kinds of vertical circular motion. One, constant speed, which is like a clock hand, tak, 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 tak. It's constant. Then there's the one that's not constant, where there's a change of energy, transference of energy, conversion from GPE to KE at the bottom, and then KE again back to P at the top. So many of you stuck with the idea that you didn't read the question and answer to it. It is not always the same situation. You need to differentiate. Can? So I was a little bit shocked. Part E is a wasted mark. Really wasted. Should get one. Next, part F. Calculate the work done by the frame on the man in moving from position C back to A. Now in position C, you have GPE and KE. In position A, let's say your GP is 0, but your KE stays the same. So what happened to the total energy of the man? What happened to the total energy of the man? It increased or decreased? Oh, you all have the lost look on your face. All must answer. So position C, what energy is possessed by the man? GPE and KE. In position A, what energy possessed by the man? Let's say GP is 0, he only possesses KE. So how did the energy change from C to A? It increased, decreased, or stayed the same? Total energy. Total energy decrease. Total energy is a sum of KE and GPE. Hey. Oh, okay. There is something here that I think when I was marking, I was like, hey, how come you all don't know? Okay. I explain again, you all still don't know. So let's say it again. At C and at A. Here, GPE is max, right? Here, GPE is 0. Here, KE is, let's say, 10. Let's say the max GPE is 5. Okay? And here, the KE, is it the same? Also 10. So what's the total energy? Total energy here is 15. Total energy here is 10. So, when moving from C to A, what happened to the total energy? It decreased, right? Change in total energy equals to 10 final minus initial equals to negative 5. If the total energy decrease, the external party must have done something to reduce the total energy. If there is a fridge, right, your refrigerator is rushing towards me somehow at 10 meters per second, and I slow it down, I'm removing its total energy, right? I'm removing its K. I must have done negative work to it. Because the force was in this way, I slow it down. Correct? So this concept is a work energy power concept. Okay? And the loss in energy is the loss in GPE. Right? In this case, the loss in total energy is the loss in GPE. And the loss in GPE is mg log change in height. And the height is 16 meters. A lot of students use 7, even though in the question we specifically said, assume the mass of the man is near his buttock or at his buttocks. We even place a dot there. Oh, wait, that one is I do. So a few students use MG7, MGH7 times 2. We give you the credit if you made the mistake earlier. Did we? Yeah, I think we did. Alright, so MGH done. MG loss done. If you gave a positive value for 9 part F, we gave you only 1 mark because the work done must be negative. The concept of negative work must be there. Question? What is the energy lost through? Lost to? Good question. You turn on the fan, right? You turn on the fan. The fan starts spinning, the blades have K. Where did the energy come from? Electricity, right? So this system is probably electrically or mechanically run. So the electricity must do negative work to it. Can? Okay, next part. Part G, calculate the rate of work done by the frame on the man at B. G part 1 is the hardest question, I think, in this part, because number 1, okay, not the hardest, the second hardest, because it is a rare question. If you look at the man in position B, like this, does he have a change in energy? He has he has a change in energy. In fact, right, the change in energy is MGV. MG, right, the power, rate of work done is power equals to force times velocity, where he is moving at constant speed. At this point, his velocity is taken to be upwards at speed v. So we can plug in this speed v directly inside. And at this point, there's a very slight change in velocity, almost as good as none. You can say that the upward force F must be equal to mg. The F must be equal to mg. So we say this F goes here, and this F is equal to mg. That's why we have this value of power. That's why we can then say that power equals to mgv. Okay, so this part is a little bit harder to grasp. But that's how it is, right? No, it's a really hard question. Any questions here? G part 1. G part 2, however, is not that difficult already because the force applied and the velocity is perpendicular to each other. At the very top, in position C, the force, the net force is this way, the velocity is this way. There cannot be any change in the, there can be no power applied. So that's simply the answer for position C. So B is hard, but position C is a lot easier. Any questions here? Can use the change in GPE. But at the very, very top, right? Ready? At the very, very top, is there a vertical velocity? No, right? It's only horizontal. So you see, I show you change in GPE. over change in time for power, right? You will get this, you will get mg change in height over change in time, which equals to mg v, vertical velocity. Yes, but at the very top, and yet position C, is there a vertical velocity? Don't have. You only have horizontal. Whereas in position B, can you see? The velocity is, there's a vertical velocity. So if you know this, if you have known this, for both questions you can get 3 marks quite easily. Because G part 2, vertical velocity is 0, answer is 0. G part 1, vertical velocity is V, mgv, done. V. Or you use radius equals 7. Radius 8 is correct. Radius should be 8. Because mgv equals to v equals to r omega, this should be 8. Okay. Next, calculate the kinetic energy of the man. Half mv squared. V equals r omega. That one, this one. Okay, so I think by now a lot of you got squared off by the question already, right? But part H is more or less a standalone. It's really a standalone, right? You just sub it in, you get your answer. Part H. Half mv squared, sub, 1 mark, no problem. Part I is the one that I don't even want to go through. Can I don't go through? Because it's, okay, I should go through, but it's so difficult. If you it's smart, if you don't get, I'm totally fine, I'm cool with that. Okay, because on a bad day, if I'm having a flu, and I have my one eye very swelling, and I have my left hand crippled because I'm a left-hander, I will not be able to answer this question. Any other day I should be able to. But it's already very difficult, right? Because most other questions, even if I use my right hand, I can scribble something out. Okay? This is one evil question. But it's for your own good that they set this kind. Because A-level, I think they ran out of easy questions to set already. The questions just get harder and harder. Okay, so how? Derive expression for G in terms, the potential energy of man in terms of time only. So the height of the man goes a little bit like this. G. So how do you do that? Let me try. Let me try to explain the answer. Where is the height? Okay, so if we take the bottom to be time equals to 0, when the man reaches here at period t equal to so this is what I do. I use some values that I know. Height at t over 2 must be 2r. Height at 0 must be 0. Okay, so in my mind, at least I have these two values. But I must find one at a certain angle. And what's the height? The height will be r minus this height. Right, minus this height h. So r is here. And there is another height h, which is here. Correct, the height of the man from the ground will be this. Okay, so it will be r minus h, height of man. Goes to this, which is equals to r minus r cosine theta. When the angle is bigger to here, this is theta, this equation still holds. Because your theta goes past 90 degrees, it becomes a r minus r, then a negative number. So it's still a positive. So it still works. So you need to, this question uses this certain skill that we call modeling. You try to form an equation based on a certain values you know. Okay? And this skill of modeling, can I say, is appearing more and more in your A-levels. They specifically say, oh, let's do more of this. Okay? So, you need to be able to form some of these questions. So this is with love. It's out of love that the teacher set this question. You think we're going to set a hard question? We need to think until our head explodes, then we can think our question. So it's out of love. Okay? Although it is now bitter medicine, the good medicine are the bitter ones. So don't be so, yeah, which teacher said what? I heard it just now. But it's with love that they are doing. Okay? So once you have the height, then you can determine the GPE. Where the GPE is mg times the height above ground. So once you have that, you can just substitute this in. Okay? Any questions? The hard part is trying to have a model equation for the height, which is what I did here, the top part. GPE is the easy part because it's mg times that height. Better to ask me now because this one you go back and think you need 1 hour. You ask me, I can help you. Okay, Ken. Let me use the next page. Okay, now I draw slowly and carefully. I draw a circle. I want to find so let's say the man is here. This is my height. If the man is here, this is my height from the ground. So I start off with using the two easiest height, bottom and top. I check. I say, when the theta, and it's a circle, usually you must use angle theta. So I must decide where to put angle theta. So let's say I put angle theta here. So when it's fully up, it'll be angle theta here. When it's fully down, theta will be equal to 0. So that's my first step. I draw a picture and I try to form the idea. So I know that the height, theta equals to 0, height must be equal to 0. When the theta equals to 180 degrees, height must be 2r. So that's my first step. I construct the boundaries first. This is a skill. Construct the boundaries first. So I know that my equation, this one I should put H-E-I-G-H-T as well in full. H-E-I-G-H-T. H-E-I-G-H-T. So I know that my equation for my height, the max value is 2r. The minimum value is 0. This is my first thought. Okay? So now I must make it a bit more general. So this one is where your experience comes in. So for me, so this is where it's really unfair when I compare you to me. It's because I have so much experience. Okay? So I know that the variable here, this center part is fixed. It will never ever change. Agree? The center part will never change. So in my mind, I know that in this equation there must be a r already. Then the second part is this. When you move in a circle, there will be a sine or cosine somewhere. There will be a sine or cosine somewhere. Because it's to model the height. Okay, so here I'm like, okay, so if there's a fixed r, so can I put this fixed r in? Yes, this is the fixed r. Let me change the color. I know that this is r. So this height, I'm going to put this here. Now, there is this part that at this point is below the center. Let's call this h. Let's call it H1. Okay. What is this? How do I? So there's something I must do here. It's R minus H1. When this thing swings to the next position, let me use now green. This position, the height must still be R plus H1. So you see your H1 value, sometimes must be a positive, sometimes must be a negative. So that's my first step. So I said, okay. Now how do I model this H1? H1. What functions do you know with theta changes positive and negative? Sine, cosine? Right? Sine and cosine will change. So if you look at your cosine graph, it looks like this. Correct? Right? So it seems very easily, and you see the height is actually R cosine theta. So it's R cosine theta. But you must put a negative sign because when theta is 0, R is actually negative R. You can check. Theta equals to 0. Cosine theta equals to 1. If you just put R cosine theta, your H1 is R, positive R. Then you get double the height, so you need to add a negative sign. Okay? So here, to be actually correct, I need to add a plus here, and the H1 is on the inside. And then you have the negative sign, correct? Okay? So this is how I model the H. And then once I model the H, energy is easy because it's mgh1. So if you look at the 9 part 1, in that 3-4 lines, consider that the man in the cage at the G equals to mg, bracket, R minus R cosine theta, close bracket, 1 mark. That 1 mark is 10 minutes of thinking. How to do that in exam? The answer is don't. Do it beforehand. But if your exam you got no choice, how do you do it? Can do faster for other questions. Then you got more time to do this. I give you the second advice. If you see this kind of question in an exam, let's say question 3, you see this question, what do you do? Skip, go forward, score full marks of 4, 5, 6, 7. This one 2 marks, forget it. But if you really want that mark, you should learn it. Okay? Cosine theta is 1, then H equals to R, right? Then you got R plus R, you got 2R, which is not correct one. So you want it to be negative so that cosine theta equals to 1, H1 equals to negative R. Then you start negative inside here. Negative R, then your height will be 0 and theta equals to 0. So you need to check. You do the model, you check, do the model, you check. And you form the equation that until it works. Yes. No, height will be equals to radius plus negative radius equals to 0. When theta equals to 0. Height has 2 components. Height has R, the radius, this, plus Hy. Because height is this is height. So sometimes Hy is a negative, it brings it down. Sometimes Hy is like positive, it brings it up. If we take anything below this, the height Hy to be negative. Come, ask more questions. If not, this question time's about. Yes? Come. Still got time. Which one? The longest side, this one. The red one. This one. This for this particular value. This one. Upwards, yes. So when your theta goes past 90 degrees, cosine that theta will give you a small value, but that is negative small value. Oh, yeah. H1 is from the midpoint, where the center is, to whichever height the object is at. Then height is from the bottom. Yes. Not easy, huh? Challenging, this question. I tell you, I got only one student, I think. Okay, I got it correct, I think. But I think other classes got quite a few. I will hear like, oh, this student got everything correct. Like, whoa, impressed. I think if I'll be frank, even if I'm a student your age, I don't think I'll get it correct. I'll be like, oh man. I just go and check my MCQ. I'm very practical. I won't get it correct. I'm not that good. So this question, don't kick yourself if you don't get it, but if you get it, good for you. Okay? And now if you get it, even better. Okay, now wait, sorry, last one. Draw the graph. Draw the graph. Once you have the equation, drawing the graph is actually slightly easier. And there's a cheat code here, I'm not kidding. K stays the same, draw horizontal lines. This one, I was also surprised. You only need 3 marks, right? You know how you get the correct shape of K. You draw one straight line, I give you the 1 mark already. You just draw energy, time, K, 1 straight mark, 1. Easiest 1 mark ever. G is harder. But there's a cheat code. If you found a certain value here, just key it into your calculator. Your graphing calculator can graph it out for you. Then you just draw whatever shape your calculator gives you out to. So if you have this equation, draw it, you're done. Okay? As to why these values, you have calculated them before. Okay, you calculated them before. Right, I think that's it. We are done. If you have questions or MCQ, you can come down. I'll explain it to you one by one. If not, that's it. Thank you very much. Next week, we will start our individual class remedials. If you cannot meet, you cannot come for that lesson, you must come for another lesson. I will take attendance. Okay, attendance will be taken. Please tell the rest of the classmates who are not here.